Welcome to the Hex Devs podcast. I'm your host, Thiago.
And I'm your co-host, Stephanie.
Today we have a very special guest, Brian and Amand. How you doing?
Good, thanks.
Thanks for coming. We're very happy to have you here with us. And Brian knows a lot about many things. He knows a lot about Erlang and software development and BSD and philosophy and psychology and so many interesting things. And I think our listeners will enjoy the conversation. So thanks for coming.
Thank you. Thanks for having me.
So can you tell us a little bit about yourself, your background?
Sure. So I started programming when I was very young on DOS and later Windows machines, and I went to university for computer science for a while. And also I studied philosophy, psychology. Eventually I got into a career as a software developer. So a lot of web development, like full stack, front end, back end. So I got started with Erlang when I got really started when I had a chance to work on a little startup. It was called Makeup Stash. And there were three of us, and we were making a makeup application, a web application, and I really liked Erlang, and so I decided that we should write the backend in Erlang. So this was the backend involved a web backend, but also an ETL pipeline and a scraper, so a web scraper to scrape makeup products from all the different makeup sites on the internet, and then compile them into one database that is then used as the backend for the website.
And so, was it like an e-commerce thing, or was it more like tracking prices and stuff?
It was more like providing user features, not prices. We were looking to improve the experience of organizing makeup, shopping for it, looking for it, and sharing it with a lot of social features, and sort of a grab bag of features like inventory features, and also information. Just like, for example, if there's a limited edition makeup, maybe having some information about that that is not otherwise available on the internet. It's just because it gets taken down.
Cool. And why did you use Erlang for that?
Well, I guess I liked Erlang. I wanted to use it more. That's probably the true reason. But it was a good fit for many of our backend problems because they are distributed problems. So we were creating multiple servers that had to do all of this scraping, and Erlang is great at orchestrating that. I made a big use of the Amnesia database, which is the Erlang distributed database, and so that was something that not a lot of people do anymore, but those distributed features made it easier to process all of this different data coming in, to deduplicate it, and to do transactions on it and stuff like that.
How many sites were you tracking? Do you know?
Well, we had a target of it was hundreds, but we didn't do them all before the startup folded. So we targeted the biggest ones first, which were the slowest. So it was just a handful, like 10, but we had a system that could work on a whole number of them, and it could also spin up different nodes with different IPs or regions and so on like that for each website. So the process of scraping was also sort of based around Chromium to reverse engineer the web APIs that the e-commerce sites are using, and then get better data that way, and also to just be a lot less work than other types of scraping that read the HTML. So by doing this, we could call the, for example, Walmart API. They were using Redux at the time, and we could just call JavaScript functions on their Redux store to get their data, which made the programming model a lot simpler. So injecting JavaScript that does those API requests from inside their own browser, and then exporting that into the Erlang system, which then deals with the data and combines that, transforms that, and that all works in a big cluster.
Yeah, that's pretty cool because I had to do that something similar in the past. I did it in Ruby, I think, but it was a little annoying because my jobs would fail all the time because I would access this specific site and the site would be offline, or something would happen, like the site would be a little different, and then my job failed, and then I would notice that a day later, and I didn't have supervisors or anything.
Yeah. So that was a big part of Erlang that just made it really easy. You didn't have to. Other scraping platforms will have all kinds of supervisors that have been custom built, but in this case, it just comes with Erlang. So the jobs could be retried very easily, and it's not just that even the website might be down, but in this case, since we were using Chromium to inject this JavaScript, Chromium itself would crash into millions of different ways. And Erlang was able to wrap that and restart that in a way that I think probably makes this kind of rich scraping very hard in other contexts. But also the jobs themselves, we have a simple distributed queue. Like it's very easy to write a distributed queue in Erlang, and so when a job fails on one node, you don't know why it has failed on that node. It could be because that node is in the wrong country. Well, another element of this is all of these different makeup sites present different websites depending on the country you're coming from. So if you want to get the correct information, you need to have scrapers that use nodes from all those different places, or proxies at least. And then you can have all kinds of reasons for failure. So you want a system that handles the failures and retries them in other contexts very, very nicely. And Erlang comes built in with these types of like the supervisor, for example, that you mentioned, it will wrap any kind of failure and retry things, and you can easily migrate a job to another node or another country or something like that. You never really lose anything.
So, did you have other options at the time, or did everyone agree to use Erlang?
Well, it was just me working on the back end, so I was lucky that I could do whatever I wanted.
That made it easy.
But yeah, I mean, I was mostly looking at some of the heavy-duty scraping frameworks as other alternatives. But at the time, they were all based around HTML scraping, and I knew that I wanted to do a rich JavaScript-based scraping. Mm-hmm. So I wanted a way to run a web browser, and I did it with Firefox as well. Yeah, I knew that from the beginning. I knew that I didn't have a lot of manpower. I didn't have a lot of people to write a million little detailed scraping scripts that break every time the site slightly changes, every time there's a small difference in the HTML. So I wanted to go surface level below the HTML to the underlying data model and access that to make it more robust and easier. But this meant I needed a JavaScript runtime. I needed to be rendering the sites. And so this meant I need to run Chromium or Firefox. And I didn't know beforehand, but it turned out that neither of those are going to do this job for you without major problems. So I was using WebDriver because that's what was available. So WebDriver is an API that it's a generic API, browser independent API that lets a program control the functions of a website, like such, for example, clicking, scrolling, and loading and reloading and navigating. So this, I think today you can use different things like Chrome headless, but at the time the WebDriver API was the way people were doing it. Like that's what Selenium would make use of, for example. And this API is very buggy. It's not well implemented on any browser, and there are many places where it fails or it hangs. And then each browser has its own major bugs with this stuff. It's possible that the browser vendors don't really want to make scraping easier, so they don't really want browser automation to be that easy. So maybe they don't invest too heavily in making it very easy. But you also want to be able to run these sort of headless with as few resources as possible, so you don't have to have really big servers. So for that, I ran them in. I used an X program for Xorg that was able to disconnect the display. So there was a display. I could connect to it to see it remotely if I needed to, but they were able to run without having to run multiple instances of Chromium without, because this was before Chrome headless. So I was cutting off the head using features of the X operating system.
It's interesting. You were running all of this stuff by yourself and doing all the backend development and scraping a bunch of sites that randomly fail. And I see that Erlang is really good for that sort of problem. And you see many companies using Erlang as sort of a secret weapon, like to do these complicated things, these things that are very finicky, like very easy to break, but they do it very well, in a very performant way, in a distributed way. Like you have companies like WhatsApp doing that, like running billions and billions of messages every day. And so why do you think why do you think that happens? Like, is Erlang like a secret weapon to do this crazy stuff? That because everybody needs to do something like that, right? Everybody needs a system that needs to handle failure, and Erlang is so good for that, right?
Yeah, the one thing that Erlang really excels at that nobody else comes close to is handling failure, fault tolerance, and reliability. And that's because it deals with fault tolerance at the lowest possible level, the level of processes, of these like Erlang specific processes. And so it's a secret weapon for reliability. In that, you're never going to do better than this system. At least there's nothing out there that competes. It is still a niche language too, and that keeps a lot of companies away. And companies can duplicate the scalability sometimes, but they can't duplicate the reliability, and nobody's come close. And the reliability is there because the system was designed from the very beginning to have reliability, to have massive concurrency across multiple nodes, and their model of error handling is fundamentally different than every other programming language. The Erlang philosophy is that you always need a second system to handle the errors of maybe not a second system. When one thing has an error, you need something else to handle the error. That's the driving fault tolerance philosophy. And that applies to, so in the Erlang world, that applies to hardware as well as software at every sort of layer of the stack. So again, the Erlang philosophy, which Joe Armstrong would famously say, let it crash, is that to really handle all errors, you need two computers. The computer that error reports what it can to the other computer, and then the computer that's handling the error decides what to do, which can by default mean restarting it or returning to a known good state. And so this means removing error handling boilerplate from the happy path embracing runtime errors, and guaranteeing that it won't take down the system, because when any part of the program enters an unknown state, there's always another part in a known good state that can return that part to a known good state, that can return the error. So in a sequential program, or a typical sequential program, you have these try-catch statements that wrap up all of these other functions, and those try-catch statements are executing in the same process, the same context. A bug there will crash the error handling code just as much as it will crash the regular happy path code. But in Erlang, you put your error handling code in a different process that is supervising the process that has the happy path code. And that's the fundamental philosophy behind Erlang's fault tolerance, and they built that in the lowest level, which means an Erlang system can be made to be extremely fault tolerant.
And like, it's very common to work at a company that restarts your server every day and some stuff like that, because we can't like really handle the failures very well, and we just assume that the program will crash, but we have no good means of detecting the failures and making it fault tolerant. And you start seeing a bunch of code that handles this kind of stuff, and it's so complicated, like you're drawing a sea of complexity. But if you look at some Erlang code, like everything is kind of there for you, like everything is already implemented. So it's interesting that some people don't realize that they're building a distributed system, they need fault tolerance, and they kind of re-implement everything from scratch because maybe they don't know about Erlang. Maybe it's because Erlang is not a very popular language, you know. So how can we make that better? How can we change that?
Yeah, I don't know how you would make it popular. They've certainly tried.
I was going just to add that I don't have a lot of years of experience, but I've heard a lot of people say, this language will be the language of the future. But I've never heard anyone say anything about Erlang, except when some friends back in Brazil started learning Elixir. Then I heard them say, it's like it's built on top of Erlang. And I was like, what is that? And that was the first time that I heard about Erlang. So I'm also curious too, given the fact that Erlang can handle all of that, why is not so popular as well?
Well, there's definitely some hard parts about Erlang that make Elixir probably more appealing. Like, for example, a lot of people program very heavily out of Stack Overflow or Google, and being a niche language, but not just a niche language, but an unusual language that works differently than other languages, means that you can't just Google for the answers. You probably won't get one. When I program Erlang, I'm spending all of my research time in the Erlang documentation and reference manuals, and a few of the books in the ecosystem. But you're not going to find a lot of sort of pre-built solutions on like Stack Overflow, or you're not going to be able to Google all of your errors and stuff like that. And that might be just because of the size of the community. And maybe that's where Elixir can make a big difference, or also maybe just by the Elixir people investing in more elaborate documentation and tutorials and stuff like that. I mean, for other languages now, you can watch a YouTube video to do anything, but I don't think you're going to find that for a lot of things in Erlang. You have to sort of figure it out yourself. Another part though is it's an old language. It's from the 80s. It was started in 1985. So they're coming at this from a very old school perspective, and it still is very conservatively run language with a lot of backwards compatibility, not necessarily.
But that's good, right? That's good. Backwards compatibility is a good thing.
Yeah, it's good for maintaining the old systems. It's good for your own code, because that means in the future it's still going to work. but maybe it means that getting the latest flashy stuff is not gonna happen. So one of the common criticisms of Erlang would be that, you know, maybe its package manager doesn't have as much stuff as npm, or that its you know, libraries for Docker or something aren't as elaborate. You can get very far in other languages just by using other people's code that they've shared, and you're not going to find that in Erlang so much. Like you definitely get a lot of libraries, but it's just not to the extent of other systems. You also, it's not that easy to get into, because you have to think differently to do concurrency oriented programming. So even from your very first day in Erlang, you're already doing concurrent programming, and that's not true for any other language. Every other language, you can spend years just doing sequential programming, never doing any concurrency, and that means you never have to think about it. And when people do think about concurrency, often it's solving some kind of multi-threading problem, writing in a multi-threaded algorithm, and then they realize it's very hard, and they have to learn to think about their code differently. And in Erlang, you're going to have to do that at the beginning, because it sort of forces a concurrent model on you if you want to get anything done. So that can be a hard that can put off some people. Another thing, though, that everybody cites is the syntax. It's a very unusual syntax. It's based on Prolog. It comes out of different paradigms, and it's based on English too. It uses commas and periods as they're used in English. A comma to separate one clause or one phrase in a sentence, and a period to end a sentence or to end a statement, or like to end a function, for example. And so a lot of people find that just pretty weird. Whereas and when you do program in Erlang or another language that is very different, you realize how similar almost all the other ones are, how they follow the same types of syntax. So Erlang has a different syntax, and not everybody's going to like that syntax. So,
do you know why Joe Armstrong designed the syntax like that?
The syntax was mostly by Mike Williams, who is one of the other three creators. The three creators were Joe Armstrong, Robert Verding, and Mike Williams. Or no, wait, was it by Mike or was it by Robert? It was by Robert, I think. But it wasn't so much Joe. But there's maybe it was all of them. But there's a lot of complicated history about all of those details of the syntax, and they defend it. They still defend it. They think that there were good reasons behind it, and it is very simple once you understand it. It's simple, it's short. A big part of the syntax is pattern matching, which I think most people would agree is really a positive thing. And it's used absolutely everywhere. It's used in case statements, for example. It's used as function signatures. It's used for all variable assignment. And so pattern matching that's based on the Prolog history. Originally they wrote, their first version was a kind of a Prolog, but then they found that those features weren't quite as popular among the developers at Ericsson who were developing on the early Erlang. And most of the Prolog features have gone away, but pattern matching is the one that has stuck around. I can't remember all the reasons for all the little syntax things, but I think it's Robert Verding. He definitely still defends all of those things, and you can see some interesting videos of him talking about why he thinks that this syntax is a really big positive. And I think Erlang code is very easy to read once you know it. I've dipped into tons of other people's source code in Erlang, and part of it is the pure functional nature of it, that I've found it very easy to follow and to edit. But the syntax as well makes things very straightforward, I think.
I know that Prolog is good for like automated planning problems and logic and stuff like that, but Erlang doesn't have anything related to that. But Prolog doesn't have anything related to fault tolerance or process or anything. So it's interesting to know that heritage of Erlang, because Prolog is a very different language too, but it's also very powerful for the things that it's made to do, like logic and stuff. Yeah, that's cool. And well, imagine like our listeners will be interested in learning Erlang, and so how someone should get started with the language? What are the most important fundamentals that you need to learn in order to start doing Erlang development?
Well, you definitely, I would say it's a case where you don't want to just dive in. You want to read a book because you need to be introduced to the concepts, because it's concurrency-oriented programming. That's what they call it, and it's a different way of thinking about your program. You have to think about, you think about your program as modeling a bunch of concurrent actors in the world, and then you think about how they interact, and there are a bunch of books that will walk you through it. There's Joe Armstrong's books, of course, there, but then the really popular one that's available for free on the internet is called Learn You Some Erlang for Great Good, A Beginner's Guide by Fred Hebert from Quebec. And that one is a really well-written, sort of gentle introduction that walks you through all of the core parts of the language and gets you to think about Erlang in the way that you need to, and it's a different way. So I think just reading the book can be very enlightening because it's such a different paradigm that it gives you a new perspective on how programming can be done, even if you never actually use Erlang. Or just reading even the first few chapters of that book. So that's probably the best place to start. And then there's many other books about Erlang which go into all kinds of detail at different levels of advancement. And most of the people in the space, like the professionals working in the space, they're looking at super scalable, super fault-tolerant systems, so billions of users and stuff like that, and that's where they're concerned with. And so it's most of the books and stuff are for a very professional audience, a very advanced audience, but especially now with Elixir, there's a lot more opportunity for small companies, or for individuals, or for anybody just getting started, even, or web developers to also make use of these powerful features.
Mm-hmm. So I think that a good way to try something new is to find an open source project, for example, to contribute. Do you know any open source project that would be nice for beginners in Erlang?
There's plenty. I'm not sure off the top of my head what would be a good one to contribute to, but all the sort of big commonly used libraries are open source and would accept contributions. Some of the big ones that come to mind are the Cowboy web server, which is very heavily used web server. I think Elixir has many good examples. Yes. But I would have to think about it more.
Mm-hmm. Yeah, that's okay. Thank you.
And yeah, so something funny that happened today is that we were having a hackathon, and Brian won the hackathon by doing an Erlang project. He was trying to make the project a little better by using Erlang, and he won the prize. And this is something that I want to know, is how do you convince other people, how do you convince your manager that using Erlang is the right way to do things? Do you have to won a hackathon or something to be able to do that? What do you need to do?
I don't know. You get lucky. My manager seems very open to the idea of Erlang, but that wasn't for me. I think it's because he watched a bunch of Joe Armstrong's videos on YouTube. So maybe that's the secret. Get them exposed to some of the things, the benefits that Erlang can provide, why it's different, and how it can make a difference for delivering excellent software. I don't know what else you could do. I suppose you could advocate for it or just explain it to people. And then there's all of the success stories. There's a lot of interesting examples of big successes using Erlang that seem like it punches above its weight. Like very few developers achieving really big things. And we've seen enough of those now. I think it's a trend.
So, by listening to what we have been discussing, I wonder if there would be a scenario where Erlang wouldn't be the best tool, for example. Can you think of some example?
Yeah, well, it's got a learning curve to it. So for many sort of normal tasks that don't involve concurrency or that don't need fault tolerance, it's easy to think that there would be a better language or ecosystem to do many tasks in. But there are some things that do use a lot of concurrency that it's not for. So that the big example there is like scientific computing, which needs to have a lot of optimized. It's using concurrency to optimize algorithms to run faster. But that's not the type of concurrency Erlang does. Erlang does command and control concurrency, or operating a massively distributed system efficiently and to scale, not to make the most efficient use of hardware, which is what scientific computing is looking for. It would be very easy to write those algorithms in Erlang, but they wouldn't perform well because you need to use threading, basically. And Erlang's concurrency model is based on isolated processes. You can have shared memory between processes when you want it, but it wouldn't be up to that standard. And it's definitely not a language where you write hardware optimizations, where you're cutting your data into little bits to fill the cache perfectly and stuff like that. That's something that Erlang is too high level for that. And other languages have libraries that do that for you already. So then for the problems that don't involve concurrency, well, aside from the library support, I mean, some problems you probably don't want to do in a pure functional language like this either. It's very opinionated, and it doesn't allow you to mutate state, for example. So if your problem has that type of property, then maybe it wouldn't be a good fit.
But you can always wrap some other programs using Erlang, right? So I know that Discord is doing Elixir right now, and they needed to optimize parts of their system, and they're using Rust for that. So you can wrap the Rust part with Elixir and Erlang using nifs and ports and stuff like that. Do you know about that?
Yeah, so Erlang was designed to wrap C from the very beginning because Ericsson, when they were making their hardware, like their big switches, they needed Erlang to drive low-level hardware. And they wrote the drivers in C, and then they controlled them from Erlang. And so to make this easier, they created the thing that you mentioned called ports. So that's basically wrap anything in an Erlang process, control it like an Erlang process, and you get all the safety of the Erlang system. Erlang will handle the restarts, it'll handle configuration, it can handle data transfer between those components, but then those components itself can do the work that needs to be optimized. So a lot of these big Erlang shops, they get a lot of mileage out of having an Erlang system that controls C, specifically wraps C a lot, but Rust is becoming very popular to wrap for the same reason. And the port system makes it very easy. And if you want to go even faster, there's what you mentioned as well, the nifs, which stands for natively implemented function. And this is where you would compile your C code, for example, right into the Erlang virtual machine, so it would run as fast as possible. But then you don't get the safety guarantees of the ports of wrapping it into a process, because so then if there's some severe error in your compiled C code, it could crash the VM. But it's an option for people who aren't worried about that.
Yeah, I feel like Rust is a very good fit, a very good match, because it's a safe language, but it's also a very fast language. So it's an interesting use of Erlang and Rust.
Yeah, I think they go really well together. It's conceptually and that kind of a system where you can do your all of your higher level glue code and your distribution code and your error handling in something like Erlang, Erlang, which provides like a lot of these fault tolerance and so on, and then you can do your really optimized code wrapped up like that, and you can still get the value of having that be distributed, because Erlang can provide that to the Rust code. So I think it's a really nice combination, and it really makes an unbeatable system when you put them all together.
But then you still have to convince your manager and your team that you want to use it and it's the right fit, you know. And then like I've been thinking about this a lot, like how do you convince people to adopt a language or a tool? Because like sometimes it's the good fit, you have the experience to see that, but other people, they can't see it. Maybe they don't have the experience, or maybe they have different opinions, and it's very hard to convince them. And so you try to like slowly convince them and persuade them, but it's a challenge, you know.
But I remember that there was a panel discussion at the Polyglot conference, right? And I remember that some people said that why it was so hard for people that are like in the management positions accept those languages that are not so popular. It's because they think that it will be hard to hire people in the future, or they are thinking, okay, you can do that, but if or when you leave, who's going to take care of that? And then we're going to redo everything. So I think that this may influence that in some way, but I don't know. It's just something that I remembered, which it would be a problem, really. Like if it's not something so popular, not a lot of people know it, and you need to get some time to get used to it. It might be a barrier for those type of languages or tools to be accepted, I guess.
Yeah, I think that's a big part of it, and that maybe is why people should pick languages that developers really like and they like to learn, they're excited to learn, and that have a lot of interesting features that they have fun while they learn it, and then more people can learn the language at your company. You don't necessarily have to hire for it, but yeah, I think it's a real concern for sure. I suppose the more people you have that know a particular language, the easier it gets for the other people in your company to learn it. And I think Erlang's an example where a lot of people really like learning it, and because it's so functional, it also means that it's possible to contribute without knowing a lot, to contribute to a team. Maybe not on the big like hard parts of it, but it's safe to get started when you have a lot of pure functions, when you have a lot of fault tolerance and so on. And the fault tolerance also makes it a lot more fun to deploy and things like that. You're not so worried like you are in other languages. There's less of a brutal culture of quality control that's everyone's always worried about breaking something.
But I think it's also easier to manage a project, Erlang project maybe, because well, you need less people, right? So the system will be easier to manage, and it's not gonna break easily. And so sometimes you see companies hire a bunch of people to write a bunch of code that is maybe unnecessary depending on the tools you're using. And so maybe like you're just creating more problems and more work for yourself if you choose the wrong tool for the job. So it's something that I think about a lot, and I don't know how to solve that, but
I think one thing that would make a Erlang system a lot easier to manage is how it forces modularized code onto the team. Like it's so opinionated that you can only use these sort of tightly controlled pure functions, and everything is in these modules, which sort of separate out the code very nicely. There's not a lot of you don't have a lot of these complicated spaghetti code interdependencies. It just doesn't happen, and I think that modularization makes managing it a lot easier. For example, you can always create a new module to try to improve some other module, and those things it's so easy to just try to swap one in for the other and to test that, and to do like the dynamic testing on the system to see how things are working. So I think it makes it solves what are organizational problems in other languages that they just wouldn't come up in an Erlang system, in particular with the way that because when they designed the language, they were also thinking about scaling the team. They were thinking about scaling to thousands of programmers, and so they put things in it that force the code to work sort of independently. A big one is just the whole functional paradigm to begin with, and all the functional libraries. But it's also the module system, and that the way that all these modules can be loaded and unloaded separately, and the way they communicate with each other or interact. It provides a lot of organization and sanity, and I think it makes things that you see go wrong in other code bases of complex interdependencies and all the state getting carried around that becomes like a noose. That just can't happen in an Erlang system. I mean, unless you really try.
you see many people doing microservices now as a way to decouple parts of the system, make them separate, make them work together in a nice way. But then you also see a lot of distributed monoliths and a lot of problems related to that. So you have like a bunch of microservices and you can't really manage all of them. You need some orchestration layer that you have to build yourself, and the code base becomes so complicated and so complex, and all the interdependencies between the microservices are usually not very explicit, and then if you want to refactor them, it becomes a nightmare because you have 20 different repositories and many interactions between them, and then you have to implement some form of transactional guarantees, and all of that stuff is super hard, but people don't seem to think about that. Like, they just say, oh, microservice, let's do microservices for everything, but there's an overhead there. And I feel like if you know Erlang and you do it properly, you can make code decoupled, you can do your little services there, and you have some nice guarantees, and you can do distributed transactions like you told me some time ago. Like, you can do some interesting stuff with Erlang.
Yeah, I hear a lot of people justifying microservices based on organizational issues. Like, for example, if we do a monolith, then people will write spaghetti code because they're able to, because the code is in the same repo, the code is in the same service. So then they're gonna do all the spaghetti stuff. So the way so then they say we can fix that by making them completely separate programs, these microservices. But then, so that maybe it's true that they won't do spaghetti code like that, but now there's just huge overhead to those microservices, and
They just make like small bowls of pasta.
Yeah.
Not a bunch of spaghetti.
But also you can split the microservices in a way that is a poorly designed system, and then no one was willing to go back and fix that. So you have like a distributed monolith, for example. You have one microservice that you have two microservices, and each one is like half of another one. And if the code isn't very carefully divided to these microservices, you have other big issues, and then you end up coming up with all of these insane workarounds to try to wrangle all that. And and then the other justification is to make things scalable. But Erlang shows that you can have things in the same repo, and you can have things in the same code base, but still have them decoupled, still have them scalable. And I guess a lot of people would say, well, sure, you can decouple things, make them scalable in any language, but I guess with Erlang, because of the way the module system works and all of the functions, it's in the processes, it's just going to be a lot harder to write a big spaghetti monster. But you also get your scalability, you get your modularization. So I think scalability is not a good excuse for microservices. I think microservices are an organizational tool about different teams working on different code bases, and they're being confused as a technical solution. But there are many other technical ways to solve it that involve a lot less overhead, and that also have fewer pitfalls.
So what would you like to see in the future for Erlang? Is anything that you think is missing in the language, or?
I think there are domains that don't have a presence. So you don't have like React tools, at least that I know of. I haven't looked recently, to manage a web application from an Erlang backend. So there's plenty of sort of libraries that could be added. The language itself, I'm not sure if I have strong opinions on that. I think it does what it needs to do well. They keep improving it all the time, and they add little changes with every release, but they're always very cautious. I think probably mostly just around the community, like growing the community, getting more help documents out there, more tutorials and stuff like that. Maybe improving the documentation to make it easier for new people, like with more examples, with more elaboration on technical concepts, for example. I suppose there's other things that they could do, like, the Amnesia database is a really cool thing, but it's very old, it's very crufty, and they could completely update that. I don't think that's gonna happen, but it would be really cool if they sort of picked up that development and brought it, like they could add SQL to it, for example. They could bring out a lot of these quality of life features that other systems have, and that in the case of Amnesia just doesn't have, because it's old and it hasn't received a lot of development in recent years.
And what about LFE, the least flavored Erlang?
Yeah.
The least flavored Erlang.
Yeah, LFE is really cool. It's so if you're a Lisper, then you like powerful macros, and you like brackets, parentheses. And if you want a lot of parentheses, Lisp flavored Erlang is it's a Lisp on top of Erlang that it uses all the Erlang libraries, but it's Lisp syntax with Lisp macros. So it's fun to program in. You can go do your structure and interpretation of computer programs stuff with LFE, and you get all of these cool properties of the Erlang ecosystem and the Erlang virtual machine, all these distribution properties. So I think it's a really fun way to program. That was invented by Robert Verding, one of the creators of Erlang, and he's also created LueErl, which is Lua on the Beam. So the Beam is the Erlang virtual machine. And then there's a whole bunch of other languages on the Beam too. So like Elixir being the most famous. So you can get those distributed features and fault tolerance, Erlang libraries, and message passing and actor model semantics and pattern matching and stuff like that, with a lot of different syntaxes, with a lot of different styles of programming. So I think that's pretty exciting. That's definitely a big area where Erlang is expanding, just being a platform for other languages. And so I'm really hopeful that Elixir can make programming a lot more enjoyable by getting the Erlang semantics to a much bigger audience and in much more domains, more than just super scalable backends. But I think it could be great for all kinds of things like GUI programming and websites, of course, and just anything you could think of.
Yeah, so I learned about Erlang because of Elixir, because I started doing some Elixir a couple of years ago, and it's really nice. Like, the community is really nice, the language is super cool, it's very fast, very performant compared to Ruby, because I did a bunch of Ruby in the past, and it's nice because like the things that you need in Ruby you don't need in Elixir. Like, for example, in Ruby on Rails you do a bunch of jobs, so you need delay job, and you need a queue, and you need some form of message passing thing, and it's hard to do distributed and concurrent things in Ruby. But in Elixir you get everything for free because of Erlang, so it's really nice to be able to do that. So Erlang, the power comes from Erlang, but Elixir is a really nice tool. Like, I really like it. Have you tried Elixir?
Yeah, I've tried it, and it feels a lot like Erlang when you're programming Elixir. I'm really positive on Elixir. I hope that it gains in a lot of popularity, and I can, do some projects in it.
Let's say that someone decides to start trying Erlang, but then I feel like when you want to learn something specific, it's always good to learn something in advance of that, like before that. So let's say, what would be nice to spend some time before going straight to Erlang?
Well, I guess I think you could, if you follow like Fred Hebert's book, Learn You Some Erlang, you could go straight to Erlang. But what would be nice? Well, there's I guess it depends what you're doing, but there's all kinds of stuff. Probably just for pure ability to program, just for the pure ability to get something done, it would be a functional language like Haskell or Elm, because just like the day-to-day of like, how do I do a loop, that people who are familiar with Haskell would find that a lot more natural in Erlang than somebody coming out of like C++. So that type of thing, like the functional paradigm as a whole, that is an important intro to Erlang, and maybe best taught outside of the Erlang community, as sort of a prerequisite. How do you what is map, what is reduce, what is recursion, how do you write a recursive algorithm? Those would be what is a pure function, what is the side effect, those types of concepts. I think that would be a really important prerequisite.
Yeah, it's interesting because when you learn functional programming, you start thinking about side effects a lot, because like when you have side effects, everything becomes harder, everything becomes dangerous, So you think, it's a good advice. Like, you should learn some functional programming anyway, even if you're not interested in Erlang. So do you have any books or recommendations about like functional programming, or I don't know, how to think like a functional programmer or something?
Well, I think the standard. I really like this sort of the standard classics. Like you can watch those videos from like the 80s of structure interpretation of computer programs from MIT with Abelson and like I don't know. I think those are I think those are very enjoyable, and you can read the book like that, or the little scheme or stuff like that. I mean that's my only recommendation really. I don't have any thing more interesting than that, but I always really like those, and I also like getting into the computer itself, so the questions about operating systems, like questions about networking and then programming language theory. So maybe these things all lend themselves to one another, but those are the types of things that I like and that I like to learn from.
So Stephanie was reading the structure and interpretation of computer programs. Can you comment on that?
Yes. I was really enjoying it, but the problem is that I always have something more urgent to study. So because of my work, right? And then I always have to stop. But I'm trying to focus on that for this second semester. I'm not sure if I will able to do it, but I was really enjoying. It's really different, but it kind of makes you feel more comfortable about working software in a general aspect. It's something that they were teaching in the 80s, but it's still useful. So I really want to get back to that. I think that I went through the first chapter only, but yeah, it's really nice. It's a good suggestion.
Yeah, I think that all of those things, like from the 80s, it survived now because it's teaching fundamentals that are universal, and that will apply no matter what you're doing in any kind of programming. And so I'm all about those fundamentals, and a lot of these fundamentals were sort of best discovered quite a number of years ago in the 60s, 70s, and 80s. And sometimes people just express them so clearly that it's not going to be improved on. So I think the SICP, as they call it, is one of those examples, just a great example of that. And you always feel sort of enlightened after you work through some of that.
Yeah, software development changed a lot in the last 20 years, I think, because back in the day, I think people focused more on the fundamentals and the basic tools that you needed to know about, and you kind of have to build everything from scratch. And nowadays, courses are more focused on learning the tools to get a job, and it's fine. Like, people need a job, but it's also nice to learn the fundamentals and be able to like build something from scratch or understand how a tool works. So it's really nice to be able to maybe learn the fundamentals
and also the why of certain tools. Every tool has, or it should have, a reason why it's that way and not a different way, and these reasons are coming back to human reasons because it's always humans interacting with the system. So I think that you can see a lot of different patterns and different approaches, generic approaches that can get applied by different tools, putting different tools in certain categories, and those categories of tools are good for certain things and they're good for certain reasons. And I think exploring all those reasons, I think, is the most productive thing, because then you know when to use something or not to use something. When you see a problem, maybe you don't know exactly what tool you're going to use. Maybe you don't know you're going to use MySQL or Postgres or Amnesia, but maybe you know that this is a tool for something that deals with relations, that deals with data, how data relates to each other. And then you know there's a whole class of tools, these relational databases, and they're all doing the same thing for the same reason, and then they're different in the details, but you can identify that class of problem, and using the right tool for the job will be more of a payoff. It'll be more productive than any amount of working hard or knowing your tool inside and out. So that's why sometimes people ask, if you had to learn one language, what would it be? If you had to learn one tool, what would it be? But I never say one thing. I think that is completely missing it. I think you don't need to learn one thing. You can learn many things, and you should. And you never, I don't know, I never regret learning anything. I never say like I'm worse off for having known a little bit about something. I mean, sometimes I stop, but I never regret it.
So you never regret learning any tool? Like maybe some tools you didn't really enjoy, but you don't regret anything.
Well, yeah, exactly. So I think like you learn how something works, and you decide that I decide I'm not going to use it anymore because I don't like it, or something's better, or I was using it for the wrong thing. But I feel like it still taught me something about how to make good decisions and how to be productive, and maybe it taught me when that tool would be well used, and maybe someday I'll run into that situation, or maybe if not that one, that type of thing, that class of tool. So maybe I for example, I think this has happened to me a lot. I'll learn some type of tool, and then I'll find out that it's just not implemented very well. It has a lot of problems, but it makes sense as a class of tool. The goal made sense, what they were doing made sense, but the implementation wasn't there. And then I know, okay, well, I'm looking for that type of thing, just maybe a better implementation, and then I feel like I could be on the lookout for that. So I think that it's learning more tools is just better, and I think it pays off. And the other thing is, I just really believe that being productive in programming is about making good decisions. It's not about typing as fast as possible or just getting things done. It's about the quality of the decision, and that means you need to have reasons for decisions, and that justifications, and always trade-offs between all the different options. So when I can, I try to compile a bunch of options and really get into the concepts behind them, and so that's my approach.
So when you want to choose a language or solve a problem, how do you decide? Do you spend some time thinking about the problem, doing some investigation? And
yeah, I think, well, right now I want to break things down into questions of essential complexity at a theory level. So just purely as an abstract thing, what kind of problem is this? Is this a data problem? Is it an algorithms problem? Is it what is the core issue, and then has it been solved before, or what other approaches have people taken? How does it differ from those? So I mean, I think that you get a lot of value by working through things like that, because it saves so much time later on, and it definitely takes practice and reading to be able to classify these things or know what's come before you. But I always find that it really pays off to learn about sort of the history. I mean, I just sort of look at it as history of the people who did work before we did, and what they've already learned, what they've already tried. And that's why, trying, if you learn that a certain thing was tried and it didn't work, well, that's very, very useful.
So you kind of have this philosophical method of software development,
yeah.
Right? So you kind of investigate the problem that you have, and you ask questions, and then you kind of challenge your assumptions a little bit.
Yeah. Yeah, so I did a lot of philosophy, and that was a big passion for a long time. So, and I think what came out of that is, well, I do think you can find reasons for things, and that's what philosophy is all about, asking why a whole bunch of times. But also I think that there's a human component to this that a lot of programmers that I encounter, I think they don't realize that just how human programming is. There's a lot of sort of humanities, like there's not a lot of hard science or stuff like that. It's a lot of very abstract theory, and it's heavily involved with how people think and how people work together, how people communicate, especially communication. So there's a sort of a liberal art to programming, and so I apply a lot of stuff from my humanities education to programming, being clear about things about your code, for example, but also the sort of the hermeneutic approach, as they say, like asking the types of questions that you ask, and working hard to come up with good questions, and then also examining the history of ideas, the history of a group. So software isn't just a bunch of bits. It's also a story of the people that built it and what they were thinking and why they built it, what they were trying to solve, how they got onto it. And so I want to know all those things. Like when I learn about something, I want to know who built it, why they built it, what they were thinking, and the development that happened, because it always is that, it's right in the name, developer. So it develops and changes over time. So I have this sort of like almost like Hegelian view of software as this process, as understanding the whole process of how it changes over time. And that's how I try to approach all these problems. So it's open-ended, but also directed.
I'm really curious to know more about your path to software, because you said that you learned still young, and then you went to psychology and philosophy, and then you went to software. How?
Well, I was always a programmer. I got a computer. My dad bought me a computer when I was very young, and so I mostly played video games, but also did programming. So I was interested in programming. I just remember looking at Doom and thinking, how did they make this? This is amazing. How did they do this? And so then I wanted to understand how they did it, and I just looked into that. How do you construct software? What is going on there? And I was really interested in physics and math, stuff like that too, throughout high school. And so I went right out of high school, I went into computer science degree, and then in university I started to become disenchanted with the object-oriented Java paradigm that ruled everything, and I was not having very much fun, so I switched to topics that I thought were a lot more fun, like psychology and philosophy and humanities and even math and stuff like that. So I sort of was lucky to be able to study all of these very interesting things and then come back to computer programming later. Again, I say, although I never left it. I mean, I always was programming, even if it wasn't my main focus.
Is there something from psychology that you use in programming? Because there's a human side to software development, like you said. So
yeah, I think there is. I mean, sounds so nerdy, but when I went into psychology, I actually thought, I was thinking this, the way that these software development is happening is so anti-human. At least it was in my program, and I felt like it was, and I felt like that we should be able to discover the right kinds of abstractions or controls or ways of doing things that conform to the way that people work, because I had this idea that the programming language itself or the programming system or tools should be tailored to the human. And I mean, I'm not the first one to think of this. Like I think Donald Knuth talks about this. And so I wanted, one of the reasons I went into psychology was because I wanted to figure out what that would be. Even my reason for going into that was related to computer programming. Not my only reason, but one of them. And so I have thought a lot about it. Like what's the right level of abstraction? What's the right kind of tool? Like what, if you think about I a lot of the time I sort of analogize programming tools to traditional tools, like in construction work, for example. Like, why is a hammer the way it is? And how did that come about? Well, the answer is that is perfectly shaped to the human body, and also to the tasks that are being used. But everything is shaped. Like, why is a brick the size it is? It's so that it can be carried. And this applies to all of those things. And so I want to implement that in the software place so that people can do better things, just do things that are more amazing and more, more impressive, and make software that's really cool and really great and has tons of features and that people love. So,
do you ever ask that question, like, why is this program shaped the way it is?
yeah.
Because like it should be like a hammer, but it's more like something without shape,
Yeah. No, all the time. Yeah, I think like one concept that I found really helpful is to think about the operator. So you've got the creator of the software, then you've got the user, and then you have the operator. And the operator is someone who it's not the user, but it's someone who's maybe administrating the system, or maybe they're debugging it, or maybe they're like sort of a customer service or something. They have a different role in the system that's other than the user. And then you think, so I analogize it to construction. So you have an operator of some heavy equipment, and they have a bunch of dials. They have a lever and a bunch of buttons and a screen, and they have a wheel. And so what are the software analogies of these, and what are the roles, and what kind of things they need at their fingertips so that they can use? So it's the melding of human and machine that's really where really like all the magic happens. And that's the part that I think is really fascinating. And the systems are designed to be used by humans, but they could be designed to be more intentionally used, and not just by the user of a system, but by the developers as well, because you have to, when you're debugging your system, you're operating your system, or when you're deploying it, or you're just trying to inspect what's going on. So I think about building myself, or whoever's doing that, operator tools as well. So I think the concept of operator is underused.
Maybe it's something related to like user experience, because we talk a lot about the user, the client, and how the user is going to interact with the software, but no one talks about how the programmer interacts with his tools or his software,
Yeah.
And it's like some tools are very nice for that, like Ruby, for example, is made for programmer happiness,
Right.
But some other tools are like hard on the developer, they're not made for humans to use, but it's an interesting idea, like user experience applied to the developer himself and the operators, which are not developers, but
Yeah, so I try to think of all the software systems. A lot of people, I find they think about automation, so they're always thinking, how do we remove the human from the loop? But I think it's better to put the human in the loop and give them leverage, give them great tools that do big things that they can use with their brain. So I want to put the brains into the system and give them buttons and wheels and stuff, instead of trying to replace them with a robot. And I think a lot of people, they're aiming for a system that won't have any humans in it, so they don't think about somebody who has to sort of operate it, or maybe they don't even think about the programmers who are going to still be programming it forever. Usually these systems don't very rarely get left behind, they get left behind, but when they're still running, you still have someone maintaining it. So we've got to think about the maintainers. So I think the Ruby approach is amazing, and the best way. It really encapsulates everything else, developer happiness.
Yeah, something that makes me a little angry sometimes is people saying bad things about Ruby, because I know Ruby is not the fastest programming language or anything, but it's very nice to work with. Like, it's very nice to work with. The community is nice. Elixir is a little like that too, so it's made for humans. But then people that say that's the bad stuff about Ruby, usually they like some tools that are not very nice, like some hard tools, like they're hard to use, hard to understand. They don't make you happy, you know. So I think it would be nice if all of the programming languages were a little more focused on making developers happy and more productive.
Yeah, I have this theory. Maybe it's a bit overly psychological, but I feel like some programmers, they want a language that will punish them. That they're a masochist, and so they're not looking. They don't want to be happy, or what makes them happy is to suffer, and so then they look for something that is hard, just because it's hard. I think that happens, but maybe I'm being too Freudian.
But do you think that this also happens because some people don't want software to be something that everyone can do? It's like, oh, this is really hard, this is not for you, this is just for me. I can handle this, not you. Do you also think that happens because of this?
Yeah, I'm sure. Yeah, there's a lot of that, and I think people maybe worried that, if everyone can do it, then they aren't special anymore. But I think that's kind of maybe missing what's already happened, which is that everybody does use software now, one way or another, because you don't have to be typing in text characters to be programming. I mean, there's all of the different tools of operating software are a type of programming. It all requires certain types of logic, for example, or sequential thinking. So, even the stuff that everybody does now, it is I would say it is a type of programming, in that they are controlling a computer to do a specific outcome directly, and it's their inputs that determine what it does. So it doesn't have to be text. And I mean, you have visual systems that are programming too that aren't text. I mean, I think text isn't going anywhere. I think that's the most powerful way to control a computer. But from that extremely powerful interface, I mean, we can do a lot to make it something that's more fun, and that you can just get a lot more done in less time, that more people can do, even if programming isn't their main thing.
Is there something else you want to share with the audience?
Yeah, if it interests you, you should don't be scared. It's easier than you think, but you'll have no idea really until you try. And just go read Fred's book, and it's free on the internet. Learn you some Erlang for Great's good, and very gentle introduction. And I think that even if you don't use it, just read a few chapters, you'll feel enlightened.
Thank you very much for coming, Brian. It was really interesting. The talk was really interesting, so thanks again.
Thanks for having me. It's always great to talk to you, and I'm very glad to be on your show.
Thank you. I hope you enjoyed this episode, and I hope you learned something new today, and you should learn Erlang. So see you next time on hackstaffs.com.